In this video, we'll be looking at the amplitude of sine and cosine graphs. Now, we've already looked at the basic sine curve and the basic cosine curve. Recall that the sine curve at x equals 0, the sine is 0, and then when x is 90 degrees, the sine is 1. When x is 180 degrees, the sine is 0. When x is 270, the sine is -1, and when x is 360, the sine is 0. So the basic sine curve looks like this. Now it's a periodic function, which means that it'll start over again, and this point is identical to this one. Also going left, it'll come back down and repeat that period. So this is one period from 0 to 360. Also notice that when we're just doing a basic y equals sine x, that these angles represent our quadrantal angles. Now for cosine, when x is 0, the curve starts at the +1. And then when x is 90, I'm going to label this as pi over 2 so that we get used to radians as well. At 90 degrees, or pi over 2, the cosine is 0. And then at pi, the cosine is -1. And then at 3 pi over 2, the cosine is 0 again. And then at 2 pi, the cosine is back up at +1. So our cosine curve looks like this. And again, that's a periodic function, so it repeats itself every 2 pi radians, or every 360 degrees. So let's look at a few equations that have a numerical coefficient in front of the sine or in front of the cosine. The graphs of y equal a sine x and y equal a cosine x both have an amplitude of absolute value of a. Now the amplitude represents the measurement from the center line of the curve to the maximum, or from the center line to the minimum. So my amplitude, and since this is absolute value, when you talk about amplitude, you'll always talk about a positive number. But we could have a negative coefficient in front here, and we'll look at how that affects the graph as well. So if we were asked to graph y equal 3 sine x, there's my 4 quadrants. I'll measure 90, 180, 270, 360. My 3 in front represents how far up above the center line, and since that's all we're doing, we're not moving this curve up, down, right, or left, or we're not compressing or anything else. Then my maximum is going to be at 3, and my minimum is going to be at -3. Okay? So that from the center line to the maximum point is 3 units, and then from the center line to the minimum point is 3 units. Right? My sine curve, when x is 0, starts at the origin. And then I'm going to use this blue line up here as my guideline for my max. And then I'll use this blue line as my guideline for the min. So sine curve starts at the origin, hits the maximum at 90 degrees, comes back to the center line, and then hits a minimum at 270, and comes back to the center line. So this is one period. And it'll continue left and right, but all I'm showing is one period. The thing to notice here is that this mark is at +3 and this one is at -3. Never goes beyond those. Okay? So if I had y equals 5 cosine x, here's my 4 quadrants. Let's label this as pi over 2, pi, 3 pi over 2, and 2 pi. My maximum on this one will be 5. And my minimum, I'm going to make these the same distance. I'll label this as -5. So as long as you label these, that should be sufficient. People will, looking at your graph, will know that this is at 5. Now the cosine curve, when x is 0, begins at the top of the curve. So I have a max here, and then it hits the center line at the next quadrantal angle. It's the minimum, and then the center line, and then the maximum. So my cosine curve looks like this. Now remember, this does not go up, okay? It'll never go higher than 5 and never lower than -5. So this is my cosine curve that has an amplitude of 5. Now let's look at negative a values. If I were to graph y equals -2 sine x, again, I need this distance to be 2, and this, since it's above the x-axis, is going to be labeled as +2. That doesn't change. Let me get my 4 quadrants here. So I can label this pi over 2, pi, 3 pi over 2, and then 2 pi. Now the thing that's different than when my a value is negative is that instead of starting at the origin and heading up, like my usual sine curve did with a positive a value, this time I'm going to start at the origin and head down. So my next y value for pi over 2 is going to be at a minimum. So then after that I hit the center line, and then I hit the maximum, and I hit the center line. So my negative a value has a graph that looks like this. And then let's do a cosine curve. And this one was a positive a value. Let's do y equals a -4 cosine x. We can label this as 90, 180, 270, 360. And let me put my maximum here at 4, and then my minimum at -4. These are about the same distance apart. Okay. Now for a cosine curve, the one with the positive a value, when x was 0, I started at the top of the curve. And for a negative a value, I need to start at the bottom of the curve. So I need to start down here at my minimum. And then it just follows the usual period for a cosine. I'm going to hit the center line at 90, hit the maximum here at 180, hit the center line at 270, and then hit my minimum at 360. So my cosine curve looks sort of like that.